So today we are discussing electric field lines due to multiple charges, and what I was saying was we will finish off electric field lines today itself and let us see how much ever we can. So we will start off with two charge system and then jump into three charge system and then see where it goes, how much ever we can do. Okay. Ultimately all that is necessary is we have to get a understanding of how the field lines will be. So suppose there is a two charge system, two positive charges placed at points A and B. So here I am not really bothered about how much charge it is. Okay, that's why I'm not giving Q1 and Q2. I'm just saying we have two positive charges. And field lines, if we have one positive charge placed, the field lines we have already seen, all of them will be coming out radially outward, right?
Yes, sir.
And another thing that we have seen is with the magnitude of the charge, we can assign the number of field lines that we are drawing to the particular charge, right? So if Q charge has 3 lines, 2Q charge has 6 lines, 3Q charge has 9 lines, and so on and so forth. So the idea is that individual charge, we have seen it, that it is very easy. But when we have more than one charge, then the field line at any point will be affected by the fields due to both the charges, right?
Yes, sir.
In this case, I also have to see which charge is closer to the point and which charge is farther to the point. Is this clear?
Yes, sir.
So now understand this. The idea is I'll choose some random 4 points P, Q, R and S, and let us try to understand how the field lines at these 4 points are going to be directed towards, and then from there we can move forward. Okay,
Yes, sir.
point S is closer to point A, so electric field due to point A will have greater magnitude. Is this clear?
Yes, sir.
And the direction of electric field due to the charge at A will be away from A because it is positive charge.
Yes, sir.
Point B is farther from point S compared to point A. So the magnitude of the electric field will be lesser, EB, because the
Just we
distance.
are considering PQRS order of positive charges.
PQRS are 4 random points we have chosen where we are going to study the field lines.
Yes, sir, but without, giving whether it's positive or negative charges.
They are both positive charges.
Yes, sir.
At PQRS there is no charge.
Yes, sir.
We study field at a point. We do not study field for a charge. Field due to a charge at a point. Field due to a charge at a point. So where the field we are studying, at that point we don't need a charge. That's why we are studying field, right?
Yes, sir.
So that when we find the field, multiply it with any test charge placed over there and we will get the force on the test charge.
Yes,
That's
sir.
how we define. So these points P, Q, R and S are 4 points where I want to study the direction of electric field line due to both the charges at A and B.
Yes, sir.
For this, I do not require any charges to be placed at PQRS.
Yes, sir.
In this entire story, there are only 2 charges that are placed at point A and B, and both are positive charges.
Yes, sir.
After that, I have chosen 4 random points so that I can figure out the direction of field line due to these 2 charges at those points.
Yes, sir.
Initially, I am telling you in a detailed fashion. Later on, it will become obvious to you more or less.
Yes, sir.
Instead of directly drawing how the field lines could be, I am initially discussing the detailed part of how the field lines are going to structure themselves. Because if you want to draw by yourself at home when you're alone, you should be able to figure out how to diagnose the situation and draw it by yourself.
Yes, sir.
Now there are two charges at A and B, both are positive charges. Okay?
Yes, sir.
We have not taken into consideration of the magnitude of the charge because we are really not bothered about it.
Yes, sir.
But I have chosen both as positive charges initially because I can first study this and then go to the other situations.
Yes, sir.
Now, in these 4 random points, I am choosing to study the point S first. Generally, arbitrarily, it has nothing to do with any kind of a sequence. The electric field line at point S will be due to the electric field due to charge A and due to charge B, both, right?
Yes, sir.
So therefore, why I am saying I am going in a detailed fashion is I am actually discussing what will be the magnitude and direction of electric field due to the charge A and due to the charge B, and look at how the direction is going to come up.
Yes, sir.
So at this point S, there is no charge. I am studying the field at point S due to the charge A and B.
Yes, sir.
At point S, electric field due to point A is going to be away from point A and will have relatively greater magnitude compared to the magnitude of B because it is closer to A, correct? This point
Yes,
S
sir.
is closer to A. So because electric field is inversely proportional to distance square, we know this already, right?
Yes, sir.
Electric field is inversely proportional to the square of distance. Because I am closer to point A, I can say that the magnitude of electric field at A is greater than the magnitude of electric field due to B, correct?
Yes, sir.
Now, along the directions we have seen, electric field direction EB will be away from point B. But because the magnitude is less, I am drawing the arrow as a small arrow.
Yes, sir.
The resultant of these two vectors will be inclined more towards the higher magnitude. Correct? That means at electric field at S will be more or less towards A side, EA side, and I will draw this as ES. This is the magnetic field line direction, that's it.
Yes, sir.
Okay.
Yes, sir.
Similarly, let us go for point R. The electric field due to charge at B will have a greater magnitude compared to the electric field due to the charge at A at point R. Correct?
Yes, sir.
See, again the same story, because there are two vectors, the resultant will be inclined more towards the higher magnitude vector. Correct?
More towards B.
It is more towards B, so I can say that the electric field at point R will be more or less in this direction. Is this clear?
Yes, sir.
Okay. Fine.
Yes.
Similarly, at point Q, electric field due to B will be having greater magnitude, EB, and electric field due to A will have a smaller magnitude. The resultant is going to be in this direction. Is this clear?
Yes, sir.
Here, electric field due to A will have greater magnitude, and because positive charge away from it, and due to B will have smaller magnitude. So this is electric field due to B, this is electric field due to A, and the resultant of these two will be somewhere in this direction. This is electric field at EB, correct?
Yes, sir.
I will just add one more point for our understanding. Along the line joining AB, if I take some point, let's say T, the electric field due to A and B both will be in the same direction, correct?
Yes, sir.
So basically I don't get two lines, I get the same line, and the resultant will also be in the same direction, correct?
Yes, sir.
Is this clear?
Yes, sir.
Now let me just draw the same thing over here. There are two positive charges, okay?
Yes, sir.
And somewhere over here we are getting the electric field line something like this, correct?
Yes, sir.
Somewhere over here we are getting the electric field line something like this. Over here we are getting something like this, and over here we are getting something like this, right?
Yes, sir.
Is this clear? And one more point along the line. So here also we can show something like this, correct?
Yes, sir.
If you remember, in the last class we have discussed that there will be a null point somewhere in between both the charges, where the net electric field will be 0. So at that point there will be no electric field. So we cannot show any field line passing through that point or region.
Yes, sir.
Another thing I want to tell you, when we go very close to positive charge, the effect of this positive charge will be less, right? Very, very close.
Sir, could you think?
The effect on me due to earth is more compared to the effect on me due to sun,
Yes, sir.
because I am very, very close to earth.
Yes, sir.
So what I am trying to say is, when we go very, very close to one charge, the effect of it, the magnitude of it, will be more compared to the other charge.
Yes, sir.
So the effect of sun is negligible compared to the effect of earth that is there on me.
Yes, sir.
So can I say, very close to this positive charge, the field lines will behave as if only this positive charge is existing.
Yes, sir.
Similarly, very close to this positive charge also, it will behave as if only this positive charge is only existing.
Yes, sir.
Only when we come a little bit farther distances, the effect of both the charges will matter, because magnitudes will be comparable.
Yes, sir.
Correct?
Yes, sir.
Now, look at this, how I am drawing. So along this line, I can't draw a particular field, because eventually it will reach a null point, right? But I can say a field line that is emerging from here will basically go something like this. A field line emerging over here will go something like this.
Yes,
Are
sir.
you getting my point? So suppose if I choose some point over here, I take effect of this, effect of that, get the resultant, then that resultant will be tangential to this curve.
Yes, sir.
Similarly, an electric field line that is emerging over here will be something like this.
Yes, sir.
Electric field line along the line, extended line, will be along the, away from both the charges, right?
Yes, sir.
And something like this, something like this, something like this. So basically, how can I draw? I can say the field lines are going to be. Is this clear?
Yes, sir.
So wherever this region is there, there I will not show any field line passing. Everywhere else I will show that there will be field line something like this. Understood?
Yes, sir.
And on field lines we also show the arrow Basically this arrow is telling the direction where the field line is going, right? Is it going from charge to outside or from outside to inside? How it is coming? Is this clear?
Yes, sir.
Understood?
Yes, sir.
So this is basically how the field lines look for 2-point charges which are positive in nature. But this is how you can alone also figure out by going into details. Suppose if you get confused how they are going to look, you can just figure out, okay, what is the effect of this, what is the effect of this. And this particular resultant line that we are getting will be nothing but tangent to the curve passing through that point.
Yes, sir.
Understood?
Hmm.
Because anywhere due to 2-point charges, we cannot have a field line as a straight line. It will be a curvature,
Yes, sir.
always varying, right?
Hmm.
Its direction.
Yes, sir.
Only along the lines I can say it is straight line, correct?
Yes, sir.
Another point, if this is null, if this is null point, then I will have a vertical line where, if you remember that e cos theta used to get cancelled, and both, do you know?
Yes, sir.
E sin theta gets cancelled,
Yes,
2e
sir.
cos theta. That happens along this vertical line, and that vertical line passes through the null point, intersection of null point and intersection of this particular line joining the charges. Is this clear?
Yes, sir.
Only in the null region we will not show any vector, but along this line also we have field. And along this line the field is along a straight line.
Yes, sir.
Along the line joining the charges also it is along straight line.
Yes, sir.
All other are curvatures.
Hmm.
Is this clear?
Yes, sir.
Xerox.
So PQRs are just some random points.
I chose PQRS for random points to discuss with you how I can do things alone also by figuring out individual directions, understanding whose magnitude will be more, whose will be less relatively.
Yes, sir.
Understood? This is not exactly specific because we did not mention how much charge is there, but more or less this is how we can figure out for any number of charges.
Yes, sir.
And an extrapolation of that imagination will give you this.
Yes, sir.
So we'll discuss two negative charges right now. Okay. So instead of going into deep and all, because you understood, right? If you take four random points and find the fields due to individual, you can draw those things that I have said. Yeah.
It will be the same thing.
It will be the same thing, but it will be in the reverse direction. Arrow is important in field line because field is a vector, right? So, like you said, along this line it will be towards the negative charge. Along this line also it will be towards the negative charge, correct?
Yes, sir.
Somewhere at this point, the field due to A will be more, field due to B will be less, magnitude I am saying because of distance. So at this point it is closer to A, so magnitude will be more, here magnitude will be less, but the resultant will be inclined towards the more magnitude fellow. So basically it will be something like this, right?
Yes, sir.
So somewhere from outside we are coming and it is good. Similarly from here also you can show something like that only. Somewhere from outside it is coming like this. So the field lines everywhere are going to look this way, like this, and let us say one more line this way, one more line this way, right?
Yes, sir.
One line like this, say. Here also also, but all these field lines are going towards the charge.
Charge. Yes, sir.
Now, in this region, somewhere over here, I am not drawing anything because it is the null point, right? Where the net electric field
Yes,
in
sir.
both the charges is 0. And also along line passing through that null point, it will be towards the null point. Is this clear?
Yes, sir.
Towards the null point. Done?
Yes, sir.
Now we have to show arrows for every line. So arrows are going to be towards our charges. Right? So the electric field lines due to combination of two charges is going to look like this. Is it clear?
Yes, sir.
Xerox. Here, I want you to take a look at not a 2D perspective, but understand the 3D perspective, which also for the previous one, two positive charges, also applies. But I did not want to confuse you. So you now understood due to two positive or two negative how the field lines are going to be on board, right? 2D on a plane.
Yes, sir.
But in reality, it's not going to be just a 2D perspective. It is going to be a 3D perspective.
We take magnetic field and compass.
So all the field lines are going towards the negative charge in this way.
Yes, sir.
And same replica is happening from there for the other charge. All the field lines are converging towards this negative charge.
Yes, sir.
In a 3D perspective.
Yes, sir.
So actually, the line that I have drawn over here is not actually a line, it's a plane. The vertical line, if you imagine, there are infinite vertical lines.
Yes, sir.
Correct? And this line joining the charges will be a single line only. It will not be a plane.
Now again, if we consider a plane, when we go further from it, again the effect decreases.
If we consider
I mean the plane along the null vector, then the center.
a plane passing through the null point.
Yes, sir.
Yeah.
Then this exact center line, if we go farther from it, again the field decreases.
At the null point, the field is 0.
Yes, sir.
But this line that I am drawing over here, vertical line, is not just a line actually. There will be many lines like this. And this is the null point where the field is 0. There will be many lines like this.
Yes, sir.
So actually this line that I am showing is a plane.
Yes, sir.
Whereas this is actually line passing through the charges is going to be a line itself.
Yes, sir.
Line joining two points will be one line only. But if there is a line passing through one point, which is the null point, you can draw infinite lines like that.
Yes, sir.
Because there will be a plane that is cutting through like this.
Yes, sir.
Clear? And it will be a 3D symmetry also, if you understand.
Yes, sir.
And my English is going crazy day by day. I think there is double M, right?
Yes, sir.
Now you learn Sanskrit, I learn English. Yeah. The 3D perspective means 3D symmetry is also existing. That means when I choose a point at this distance, blah blah, there will be exactly another point which will be same distances from both the charges and will have the same magnitude of the resultant electric.
Yes, sir.
Is this clear?
Yes, sir.
And each of these lines will be more or less, we can say, parabolic kind of a thing. A parabola.
Yes, sir.
And if you imagine, if you imagine this one particular line and rotate it in 3D, you will get a cup or bowl kind of a thing.
Yes,
Like
sir.
Only one line. Like that,
Yes.
there will be many lines. Compress, expand.
Yes, sir.
Like flower, each of it being a petal of a flower. Like a
Yes,
flower,
sir.
right?
Yes, sir.
Symmetry similarly on the other side exists. Is this clear?
Yes, sir.
Okay.
Yes, sir.
Naming, even for magnetism purposes and also for electrostatic purpose, naming here comes into play. I will call this fellow as a axial line. Line joining charges, line joining magnets. I'll call it as an axial line. Because,
Yes, sir.
because this axis is passing through the charges. I call it axial line. This
Yes,
is
sir.
an axis passing through the charges. This particular fellow line, I will call it as equatorial line.
Because it's exactly dividing the two.
Because
sides.
it is passing through the null vector, null point.
Yes, sir.
You can say it is dividing also, is correct only. There's nothing wrong in it. What you want to say is symmetrically it is dividing on left side and right side.
Yes, sir.
Okay, so that way also it is appropriate to say that it is equatorial line, right?
Yes, sir.
But because it is not just one line, you can also mention that there is an equatorial plane. So how to remember this is axial line and this is equatorial line? People forget that. When a faculty is telling, great. But usually students forget that. So how to remember is axial line is just one line that exists. Only in equatorial situations you can have a plane.
Yes, sir.
Okay.
So we can remember like this also. I mean, the Earth's axis thing is only one line, but
Equator is a plane.
yes, sir. It's joining through the null point from it.
I am still learning about equator of Earth. Literally. Because the axis of Earth is actually tilted. So I'm right now trying to figure out how the equator, from where it passes through in real life, not in ideal situation. Ideal everybody knows. Just for fun. Zeros. So we have looked into two positive charges, we have looked into two negative charges, and also we have tried to understand the three-dimensional perspective rather than just the two-dimensional perspective.
Yes,
So
sir.
there will be infinite equatorial lines in a 3D space for two charges.
Yes, sir.
Is this clear?
Yes, sir.
Now let us go for a combination of positive charge and a negative charge.
Yes, sir.
Positive charge will send the field lines away from it,
Yes, sir.
whereas the negative charge will get the field lines towards it.
Yes, sir.
So between the charges lie along the axial line, definitely the field lines will be from positive to negative. There is no doubt about it.
Yes, sir.
Similarly, as we go along at a particular distance, this positive will be there, negative will be here. Eventually, from positive to negative, we will have like this.
Yes, sir.
Here also, we will have something like this. And this goes on till whatever extent it can go on.
Yes, sir.
Upper direction also, it goes on till wherever extent it can go, correct?
Yes, sir.
Now, some field lines which are coming from here,
Go away.
the effect of it might not be much as of the positive charge, so it goes away, right?
Yes, sir.
So you can say something like this, right?
Yes, sir.
Here also you can say something like this.
Yes, sir.
But the difference is here the arrow is away from the positive,
Yeah, away.
right? But here the arrow is towards the negative charge. Is this clear?
Yes, sir.
I have a problem. For this positive negative charge situation, the null region will exist somewhere over here outside of the extended line joining the charge. Outside the, not between. Why? Because due to the positive charge, the field will be in this direction, due to the negative charge, and wherever the magnitudes will be equal, they will cancel each other.
Yes, sir.
So this will have a null region somewhere over here. And more or less in this direction, here also I will have a null region. Is this clear?
Yes, sir.
There is a possibility depending on the magnitude of charges.
Yes, sir.
Understood?
Yes, sir.
But every other field line will basically look like this.
Sir, but
Yeah.
this arrow towards the null charge and one arrow towards the positive charge, so won't those both get cancelled?
Here?
No. Sir, how do I show?
Tell me where.
Sir, at the positive charge, yes, sir, there's one away from it and one towards it.
Where?
Yes, sir, that line.
All the lines are away from it. When you are very close to Earth, the effect of Earth is more.
Sir, won't those both cancel? The two away things?
No, it's not like I'm sitting at the center of the charge. On Earth, if I am here, my electric field, let's say, is away from it, radially outward. If you are in Australia or USA, which is opposite side of the globe, so that these two lines are not acting at a given point. These two are arrows for two different points.
Yes, sir.
Sun is radiating light.
Yes, sir.
Now, if you apply the same logic, that means here light and there light should cancel each other, but that doesn't happen because they are occurring at two different points, two different regions.
Yes, sir.
Yeah.
Yes, sir.
Bomb is blasting, small bomb. You can say that no, nothing will happen because the blast that is occurring in this direction will cancel that direction. So I can hold the bomb in my hand and light it up. So great, nothing will happen. Kaboom! No hand. The field lines that we are drawing near the charges are at different points surrounding the charge, but they are very close to the charge, therefore all of them will be away from the positive charge.
Yes, sir.
Similarly, all of them will be towards the negative charge.
Yes, sir.
If you look at the region that is closer to the positive charge, the field line is away from it. But I said somewhere there is a chance to get a null region depending on the magnitude of the charges.
Sir, in the null region, you like both of the field lines are away from each other.
Will cancel each other. Opposite direction,
yes, sir.
Equal in magnitude, will cancel.
So one field line is of the positive and the other one
due to the negative.
Yes, sir.
And they will cancel each other. So this null region is nothing but zero electric field point, right?
Yes, sir.
There also null region is a zero electric field point.
Yes, sir.
If the field line, if you look at it, close to the positive charge is away from it, and it reaches a null region, then after crossing the null region, that means that the field line should basically reverse its direction. On x-axis, when you go from -5, -4, -3, -2, -1, and if you are crossing 0, that means you have to go to 1. If that train is further going ahead, it has to go to opposite direction of this whatever minus we had. -4, -3, -2, -1, 0, 1, 2, 3, 4, 5.
Yes, sir.
Right? So the only way this creates a null region over here is when the magnitude of the electric field due to the positive charge is cancelling the magnitude of electric field due to the negative charge.
Yes, sir.
But I have a doubt. If that is so, why is it not cancelling over here? Because the magnitude of positive charge is greater than the magnitude of negative charge. How can I say that?
If you go closer
to the positive charge, the effect magnitude of the closer charge will be more. Effect of the closer charge will be more than the farther charge. But as we go farther and farther, that's why I said there is a chance depending on the magnitude of the charges.
Yes, sir.
Suppose you have 1 million coulomb over here and you have 1 coulomb over here. Right? So that's why I am saying depending on the magnitude, there is a chance to get a null region somewhere. But if we come across this null region, that means while you are going from positive charge to null region, the effect of negative charge is increasing and the effect of positive charge is decreasing, right? Not increasing, not increasing exactly. It will never increase, right? As you are going farther, it will always decrease. But what we are trying to say is that the effect of negative charge is coming relatively closer to the effect of the positive charge.
Sir, but that null point is more closer to the positive thing.
Correct. That's why I took the example that if I have, suppose reverse, if I have 1 coulomb here and 1 million coulomb there.
Yes, sir.
Very close to the 1 coulomb will have more effect, just like sun and earth. Right?
Sir, can the null point be here or I mean exactly between positive and negative away from it? I mean,
here?
we do it like a locus thing, no, sir.
Here?
No, sir, very below.
Here?
No, sir. I mean, very away, just below it.
Here?
Sir, how do I show?
Just below what?
The last line.
Just below the last line, here?
Yeah, more further, more deep.
No, that means we are going to infinity, right? When we are showing field lines, the extreme line that we are showing is more or less, we are saying that more or less is the last line, and what we mean actually is after that you're talking of infinities, infinity distance from positive charge and infinite distance.
So there will be a null point there.
Infinity is an undefined point. How can you say it's a point in the first place? Therefore we don't say null point.
Yes, sir.
It will be a defined point first to discuss about. I have a point, but there is no electric field over there, so it is a null point. I
Yes.
don't know what it is.
Yes, sir.
It's at infinity, that is an undefined distance. I don't know where I am. So what should I discuss when I don't know where it is?
Yes, sir.
Right?
Yes, sir.
But what I'm trying to say is that the nature of the direction should change if it crosses a null region. If it crosses a same over here. Over here, if we show that the field lines will be towards the negative charge, if it crosses a null region, after that it should be towards the away from the negative charge. Is this clear?
Yes, sir.
Again, this can be treated as a three-dimensional. These are all eggs in between,
Yes, sir.
right? And these are all parabolas coming out, cones
Yes,
coming
sir.
out. There also we have cones, but they are going in. Rocks.
Yes, sir.
See, we have discussed all two charge possibilities. I want to finish off by discussing one three charge possibility. That way we can put a full stop to the electric field lines, because field lines is not a problem to. Once discussed this much, field lines will not be a problem to anyone, in fact. Okay, so let us discuss 3-point charge system. Let us see for all three positive charges. Let's not complicate it. I only want your imagination to be improvised. That's the only reason. Okay.
Yes, sir.
See, something like this, and it is an equilateral triangle. Let us make it complete symmetry. Equilateral triangle, so something like this. That means this fellow is also yeah.
Yes, sir.
Something like this. This much is obvious, right?
Yes, sir.
Arrows also we will show, right? Because all three are positive charges. We have no doubt about the direction part. Yeah.
Yes, sir.
Clear?
Yes, sir.
Now further, if I want to look at, I can say something like this will come up, right?
Yes, sir.
Same goes over here also. Something like this will come up. Same goes here also. Something like this will come up. Fine?
Yes, sir.
I want you to imagine. I want you to imagine the 3D version of it.
Yes, sir.
Same thing is happening like this also, it is coming out. Right? So
Yes,
this is a equilateral triangle. Let us write this as equilateral triangle here. If you look at, the null point will be at the center, right? Because all three are equal positive charges.
Yes, sir.
At the center of the equilateral triangle. And that null point will have one equatorial line.
Yes, sir.
Which is passing through this particular point, right?
Yes,
Something
sir.
like this. In this case, the equatorial line will not be equatorial plane, cannot be.
Yes, sir.
So there are bushes coming out of all these positive charges from everywhere. Only one line we will have.
It can be only one, so that will be the axiom.
We don't know that. We don't. There is no axial thing in this. Axial is only when you have 2 points. We call it axis.
Yes, sir. Yes, sir.
One line, and that is equatorial line passing through the null point. And the null point will be at the center. This is only the null point. Is this clear?
Yes, sir.
So for us in exams, he can give a 3D representation. So that imagination is all that is very important. So everywhere we are getting the lines coming out. Right?
Yes, sir.
Everywhere coming out. And this one line is the equatorial line. Above the plane of what we see, the field will be along the equatorial line away from it.
Yes, sir.
Behind the plane that we see, the field will be along the equatorial line away from the null point.
So 2 different
Direction. Is this clear?
Yes, sir.
We will discuss questions on this, not on field line, but we will, when we discuss a question on this, you will get the idea of the equatorial line that we're discussing of.
Yes, sir.
Okay?
Yes, sir.
Xerox.